All right, and here is our official derivative rules for constants. Remember, we ended with logarithmic differentiation before. So here is the pattern. Like if you wanted to write it down the same way that we memorized that the derivative of ln is 1 over the stuff, it's the same deal here if you want to memorize, but you don't have to if you're willing to do logarithmic differentiation. So again, this is only when the base is a number and it's raised to a power of x. Okay, so we could just follow the shortcut on this. Last time we did notes on logarithmic differentiation, we actually used this exact same problem. So if I wanted to just follow the pattern, it would be, do you remember what it was? Keep the same thing, and then I have to remember to also divide by ln of the base. And that's it. Okay, so on the second one, I think the answer is going to be, what do you think it's going to be? I think it's going to have 3 parts because sine has a derivative, right? So we're going to get the whole thing back, then we're going to get an ln of the base, and then we're going to get the derivative of the extra stuff. So I think it's going to look like that. Now I'm going to go ahead and do a logarithmic differentiation on this one again real quick so that you can just see that it would still work. So I'd have ln of y, ln of 7 raised to the sine of x. Sine of x would go to the front. So I'd get sine of x times ln of 7. Try to remember that ln of 7 is just a number. So when I take the derivative of this side, it's still just going to have the number in front, but now it's going to be times cosine. And on this side, I'm going to have 1 over y dy. Okay, so when I move everything over, we're going to have dy over dx on this side. We're going to have ln of 7 on this side, cosine of x on this side, and then y on this side, which is going to turn into the original problem, which was 7 sine of x. So does it follow the same pattern? Let's go take a look. We had keep the original, keep the original. We had ln of the base, ln of the base. We had derivative of the extra stuff, derivative of the extra stuff. Okay, so if you can't remember it, logarithmic differentiation is the way to go, right? All right, the more difficult ones here are the log derivative rules. And again, we've done ln, so these are log derivative rules. And here the pattern is you're going to take whatever the base is, which is a base a, and you're going to make sure there's a ln of the a. The u is going to also go under, and then you're going to have the du. Okay, to me this is super annoying and I can never remember what to do with it, all right? So here's what I would do is we're going to use one of those other formulas called change of base, and it was on one of the prior pages, and it says basically anytime you do not like the base of something. So let's say I had log base 6 of 7 and I didn't like log base 6 for whatever reason. I could rewrite it as any other log base, including ln, as ln of 7 over ln of 6, and just write it like that instead. Okay, so I'm going to choose to do it that way first instead of just following the formula. I'm going to call this ln of 6x over ln of 5. Now remember, ln of 5 doesn't have an x with it, so that's just a constant. So this is really just 1 over ln of 5 times ln of 6x. Don't like that, I can expand it out one more time, and I could call it 1 over ln of 5, and then I could do ln of 6 plus ln of x, and now the only place that I really have to take a derivative is right there, right? The derivative of this would turn into 0, so when I'm ready to take the derivative, I would have 0 plus 1 over x, and then on the outside, I would have 1 over ln of 5. So this would turn into 1 over x ln of 5. You remember what the pattern was in the rule? It was 1 over ln of whatever the base is. That's this part right here. And then it was also times, what was it times? It was times the derivative of u. Right, so my derivative, my ending derivative is 1 over x times ln of 5. Let's go and use their formula and see what we would have gotten had we used their formula. So their formula says I should just write 1 over whatever the u is, so that's 6x, then ln of the base number, which is a 5, and then at the end, it is multiplied by anything else. So multiplying by 6x is times 6. Those would cancel, and I'd end up with 1 over the quantity x times ln of 5. They match. So you can either use the formula in the box, or you can just use change of base and switch it into ln's and then use some log rules. Okay, so let's try the next one. So in the next one, let's see. I'm going to do ln of 3x plus 1 over ln of 2. Okay, next step is I'm just going to think of that ln of 2 like a constant. So I'm going to call this ln of 3x plus 1 with a constant in front of it of 1 over ln of 2. Okay, so I just really have to do the derivative of the top. So the derivative of the top, it's going to have a 1 over ln of 2 anyway. So we're going to do 1 over 3x plus 1 times the derivative of 3x plus 1, which is 3. So I'm going to have a 3 over ln of 2 times 3x plus 1. Okay, and that's going to be our final answer. So we're using change of base formula right here. Okay. All right, what about the last two? Do you want to use the formula or do you like the change of base? I actually like the change of base formula. It's more awkward for me not to use it than to use it. So here it's a log, right? I can use the power to the front. So I get to call this 6 log base 3 of x minus 3. Okay, I'm going to call this 6 ln of x minus 3 over ln of 3. Remember, when you're doing change of base, you're keeping both logs, and you can change them to any type. Log base 2 instead of log base 3, log base 10, ln, it doesn't matter. I use ln because it's faster and easier to write. Okay, all right, I have not taken the derivative yet. So now we're ready to take the derivative. I just have to remember that I have a constant called 6 over ln of 3 in front. And now I'm going to take the derivative of this part. Okay, so this is going to be 1 over x minus 3. X minus 3 only has a derivative of 1, so we're done. So this is going to be 6 over ln of 3 times x minus 3. Cool. All right, let's see what we can find out in number 8. Again, I can move the 2 in front. So then I'll have a 2/3 log of 15x. And I can leave it like that, or I can break it out. Let's see what happens if I leave it like this. So this is just going to have a 2/3. What else do I want to do? It's already a log, right? So it's a log base 10. So I'm going to choose to call this 2/3 with an ln of 15x over an ln of 10. Okay? All right, so we still have to take the derivative of this. So again, remember that only the one with x is really it. So this is really 2 over 3 times ln of 10 times the part that has the x in it. Okay, so here we go for derivative. So this is the constant that just stays in front, 3 ln of 10. And then I'm going to take the derivative of the ending thing, which is 1 over 15x times 15, and then it's just a whole bunch of simplifying. What could I simplify? Well, the 15s cancel for sure, right? So now I just have 2 over 3 ln of 10, and then we just want to make sure the x is not part of the ln. Awesome. Let's practice.